Welcome to lesson 4.7, isometries or isometries. Depending on your pronunciation, I go with isometries. So isometry, or what is an isometry? Well, we've already kind of looked at this, and in our last lesson, we ended the notes with a table describing different transformations by how many reflections they were. That builds into this idea of isometry. Isometry is a transformation that can be created by composing reflections. So it's all based on multiple or one reflection. So what qualifies as isometries? Reflections, translations, or our slides, and rotations are all examples of isometries. Single reflection over a line is obviously a reflection or a flip. A reflection over two parallel lines is our translation or a slide, and reflecting over intersecting lines is a rotation or a spin. Things we've already established and looked at. So then let's get into these ideas a little bit deeper. So what happens if we're reflecting over three lines? So we're no longer going over two. Now we're Now we're dealing with three lines. So any reflections over three lines, the orientation is reversed from the original because there's an odd number of reflections. So that tells us it can't be a translation or a rotation since those both preserve orientation. So if we're doing anything over three lines, we know it can't be a translation, can't be a rotation. So then, the next piece, it also tells us to examine all cases of composites of reflections over three lines, consider how many points of intersection the lines can have. There are only four possibilities or cases, which would be the lines intersecting at 0 points, never intersecting, the lines intersecting at 1, 2, or 3 different points. So what results do we get when we're doing these reflections over three lines? So case 1 is if there's 0 points of intersection. So if we're doing three reflections and there's 0 points of intersection. So this example here, case 1, they're taking triangle ABD, reflecting it first over L, then over M, and then over N. And that results in triangle EHF. So that final resulting piece would simply be a reflection over another line or a fourth line that is parallel to the original three. So what ends up happening is EHF, this triangle, is the result of taking ABD and simply reflecting it once over P. So if we're reflecting over three parallel lines, our result is the same thing as a reflection over just one line that would be parallel to the other three. Case 2 is what happens if these three lines all intersect at one point. So our three different lines intersecting at one point. So what happens here? Well, let's see what they tell us in our notation. So we are beginning here. We're reflecting over S, then reflecting over T, then reflecting over V. So what that ends up doing is giving us this final image down here. So what really ends up happening was our result is a reflection over the line that is concurrent, meaning also crosses the middle of our other three. So the result is going to be a reflection over this fourth line of Q that wasn't originally there. So if our original lines were S, T, and V, and we are going over all three, that's the same thing as taking this and reflecting it over Q. So first one was a reflection resulting over a parallel line. Second one is a reflection over a line that's concurrent, meaning they all meet at the same point with the other three. In case 3 then, what if we have 2 points of intersection? So our pre-image here, our final image here. What ends up happening is we're reflecting over M, then N, then P. So this gets reflected over M, then over N, finally over P. So what was our final result here? So there's 6 possible orders in which you can do these reflections, no matter what. So when there's 2 different points of intersection, no matter what order we go, the composite is a combination of either a translation or a rotation and a reflection. So in this case, what ended up happening could have been this rotates down to here and then slides, or not slides, it rotates and then reflects. Or it could slide, so slide from here to here and then reflect. So in this case, when there's 2 points of intersection, the result, the composite, is either a slide and a reflection or a rotation and a reflection. And then lastly, we have case 4 with 3 points of intersection. So for this case, regardless of the order in which we go, so no matter which order we go with these reflections over these 3 lines, the result is always going to be a rotation followed by a reflection, or a spin followed by a reflection. So if I took my original, rotated it down here, and then reflected that over line N, I would end up at my final point. So the key here, cases 3 and 4, if we have 2 points or 3 points of intersection, those cannot be described in terms of a single reflection, rotation, or translation. It turns out that whenever an isometry cannot be described by a single reflection, rotation, or translation, we call that a glide reflection. And a glide reflection is a reflection that's followed by a translation or a slide in a direction parallel to the reflection line. So a glide reflection is we reflect and then we use a translation in a direction that's parallel to the reflection line. So if this would be reflected down here, then it's slid over here parallel to the line to get our final image. Or this, then it would be a reflection over a line, flipping it, and then it's a slide. So let's look at this idea of glide reflections. Glide reflections say, let r lowercase m be the reflection, and then the capital T be the translation with a non-zero magnitude in direction parallel to m. So then glide reflection equals the capital T being the translation, and then the dot rm. So that's our way to notate a glide reflection. So then our final piece, looking at these examples here, example 1 says identify the isometry that maps one image onto the other. So we're saying, is it a rotation? Is it a translation? Or is it a glide reflection or just a reflection? So looking at A, the hand has the same orientation. The thumb is here. I can see the palm. thumb is on the left, I can see the palm, so I know it's oriented the same way. So if I have the same orientation, I know it's either a rotation or a translation. But because the angle of the hand changed, translation would just be a straight slide. So this has to be a rotation to get the angle of the hand to change. In B, I have different orientations. In the first, the thumb is on the left with the palm exposed. Second, thumb's on the right with the palm exposed. So different orientations tell me this is either simply a reflection or a glide reflection. Well, if I just took this palm and reflected it, it would end up over here at the same angle. So because the angle changed, what that tells me, and the piece looks like it's shifted, if this was going to be just a reflection, I'd be up here. If it's a glide reflection, that means I can flip and slide. So this must be a glide reflection because we have different orientations and it's more than simply flipping one of these to be in the other spot. In C, this one's kind of easy to tell because if it was, again, just a slide, the flag would be still on the top. If it was just a rotate or just a reflection, it'd be right down here. And if it's a rotation, the flag would be facing out to the left. So this is a flip. So flip down and then a slide over. So a flip and a slide makes this a glide reflection. And then in this case, D, this flag could just slide along a vector this way. So this would simply be same orientation, just a slide or a shift. So that isometry is a translation. So the main idea, as long as you know these four cases, take the info right from your notes for what the results are. 0 points of intersection over 3 lines. Our final reflection is also just a single reflection over another parallel line. Over 1 point intersection, our final result would be a reflection over a line that's concurrent to the other 3. And then in 3, 2 points of intersection means we either have a translation or a rotation and a reflection combined. And in case 4, we have a rotation followed by a reflection. Both cases 3 and 4 result in what we call a glide reflection. Otherwise, your main idea of isometries comes back to these first few bullet pointed notes.